We've undertaken research projects with professional dance companies, mainly looking at injury mechanisms and how to prevent them. We've also worked with river dance, and we've shown that very subtle changes to the dance choreography, so subtle it wouldn't be noticed by the audience, can have a marked effect on reducing the injury rates. We've analysed the fast bowlers of the England cricket team. We're looking at back injuries and how it correlates to bowling action. In fact, we analysed them just before they won the Ashes, so who knows, maybe the Ashes were actually won in Coventry. Just as we can analyse the athlete, here we're analysing the equipment used by the athlete, i.e. a new design of tennis racket. We've worked with a number of major automotive manufacturers. In this study, we're examining the loads within the body and joint angles as people get into and out of the manufacturer's own vehicles and comparing it to competitor vehicles. This information was then fed back into their design process. This subject is paraplegic. He's paralysed from the mid-chest level down. A major problem with paraplegia is that bone death occurs in the legs because the legs are not being loaded. You might notice his legs are actually moving, and that's because we've attached stimulating electrodes to the muscles to get them to fire to reproduce the rowing action. Through rowing, loads are being applied back onto the bones. The question that we're addressing in this research study is how do we stimulate the leg muscles in such a way that the loads are large enough to prevent bone death, whereas not being too large such that they cause injury to the subject. I hope you found this very brief presentation of some of the biomechanical research activities of Coventry of interest. If you've got any questions, please contact me and I shall attempt to answer them. Many thanks.